Hello guys, today we are going to talk about counter current mechanism. Counter current mechanism has two parts: counter current multiplication and counter current exchange. Counter current multiplication is by descending limb of loop of Henle. Counter current exchange is by VASA recta. Before going into counter current mechanism, we will understand some of the basic concept in the kidney by the help of this diagram. In this diagram, first we will look in this part of the diagram. In this part of the diagram, we know the kidney has outer cortex and inner medulla, which is further divided into outer medulla and inner medulla. As we go down from cortex to medulla, the concentration of interstitial fluid increases. Here we can see 300, then it becomes 600, then it becomes 1200. This change in the concentration is known as medullary interstitial osmolarity gradient. This medullary interstitial osmolarity gradient is created as well as maintained by the help of counter current mechanism. Another thing which is important here, that we know the unit of kidney is nephron, and nephron is somewhat located in this way, which we can see here. This is the glomerulus, then we have PCT, then we have descending limb of loop of Henle, then we have ascending limb of loop of Henle, then we have DCT, and finally collecting duct. The urine flow in the descending part of limb of loop of Henle and in the ascending part of limb of loop of Henle is in opposite direction. The blood flow to the glomerulus is by afferent arteriole and it goes out via efferent arteriole, finally forming the vasa recta. The blood flow in the descending part of the vasa recta and in the ascending part of vasa recta is also in opposite direction. So both in the loop of Henle and in the vasa recta there is formation of counter current. Counter current means flow of fluid in opposite direction. Now we'll go to counter current mechanism. I have already told you counter current mechanism has two parts, that is our counter current multiplication and counter current exchange. First we are going to see counter current multiplication. For counter current multiplication we have to go to the loop of Henle. This is the loop of Henle. In this is the descending part of loop of Henle, this is the ascending part of loop of Henle. The fluid concentration in the descending part of loop of Henle at the entrance is 300, whereas at the tip it becomes 1200. Why this happens? The descending part of loop of Henle is only permeable for water, not for solute. So the concentration of fluid in the descending part increases. At the entrance of descending limb of loop of Henle it is 300, whereas at the tip of loop of Henle it is 1200. So we can clearly see that the osmolarity has multiplied by 4 times and it has become 1200. This is counter current multiplication, that the fluid osmolarity has increased by 4 times. Here clearly we can see that counter current is multiplication is the function of descending part of loop of Henle. Further we can also see here ascending part of loop of Henle. In the ascending part it is impermeable for water and it is permeable for solutes. Now let's go to counter current exchange. In the same diagram, just I have added the vasa recta to explain the counter current exchange. Here we can see the vasa recta which has a U shape. This U shape of vasa recta is very important. See, in descending part of vasa recta we can see the solute is coming in and also the water flows out of the descending part of vasa recta. So the concentration of blood here increases from 300 to 1200. As it ascends, the opposite happens and concentration from 1200 comes back to 300. Earlier I have told you there is a medullary interstitial osmolarity gradient. This medullary interstitial osmolarity gradient, we have seen that in the cortex it is 300, then in the outer medulla it turns to be 600, then in the inner medulla it turns to be 1200. See, this concentration gradient is also maintained in our limb of loop of Henle and in the vasa recta. That medullary interstitial osmolarity gradient is created by the help of the counter current multiplication, which we have seen earlier, and that medullary interstitial osmolarity gradient, it is maintained by the help of counter current exchange, which is done by vasa recta. If at all the vasa recta would be straight, then there will never be the maintenance of medullary interstitial osmolarity gradient. So this U shape particularly is responsible for maintenance of medullary interstitial osmolarity gradient. In a nutshell, what I would like to tell here is, we know counter current mechanism has two parts, that is counter current multiplication and counter current exchange. Counter current multiplication is done by descending limb of loop of Henle. Counter current exchange is done by vasa recta. By the help of counter current multiplication, we are creating medullary interstitial osmolarity gradient, whereas by the help of counter current exchange, we are maintaining medullary interstitial osmolarity gradient. If guys, if you have any doubt, please comment below, and do not forget to like, share and subscribe the channel. Thank you.